Hello friends, you all are welcome in the Collegiate-Physics classes in lecture number 7. In this lecture, we will explain the center of mass frame of reference as well as we will give some example which are explained in center of mass frame of reference. As we have seen that the collision of two particles in a plane cannot be explained very clearly in L frame of reference. But that problem can be explained very easily in C frame of reference. We will see it in this lecture. So, first of all, we will define the center of mass frame of reference. Before defining the center of mass frame of reference, we should first of all define what is center of mass. Center of mass. If there are a large number of particles in a system, then the center of mass of this system will be defined as a point where total mass of the system is assumed to be concentrated. For example, suppose that there are two particles. One particle is of mass m1, another particle is of mass m2. Suppose that these two particles are along x-axis of a Cartesian system. The position of m1 is x1 along x-axis. The position of m2 is x2 along x-axis. Then the center of mass of this m1 and m2 will be at xcm, at this point, which is denoted by xcm. Then the definition of xcm will be given as m1 x1 plus m2 x2 divided by m1 plus m2. The moment of mass m1 about origin is m1 x1. The moment of mass m2 about origin is m2 x2. If m1 and m2 both are assumed to be concentrated at this Cm point, then the mass at Cm point is m1 plus m2. Its moment about origin will be equal to m1 plus m2 into xcm. So xcm will be equal to m1 x1 plus m2 x2 divided by m1 plus m2. Now, if we assume that the masses m1 and m2 are equal, suppose the equal value of m1 and m2 is m, then xcm will be x1 plus x2 by 2, that is the midpoint of x1 and x2 will be the center of mass. For three-dimensional case, suppose that a body is in 3 dimensions, then the center of mass will have 3 coordinates xcm, ycm and zcm. Xcm will be m1 x1 plus m2 x2 plus m3 x3 plus mn xn divided by m1 plus m2 dot dot plus mn. This may be written as summation mn xn n is equal to 1 up to n divided by summation mn n is equal to 1 up to n. Similarly, the another coordinate ycm and zcm of center of mass of the system can be written like this. Again, let us return to the two-point system or two-particle system. In two-particle system, the center of mass is m1 x1 plus m2 x2 divided by m1 plus m2. If we have to define center of mass frame of reference, then the origin of center of mass frame of reference will be taken at center of mass of the particle. That is, origin will be at xcm. Therefore, in center of mass frame of reference, xcm will be 0, because in center of mass frame of reference, we will take the origin of this frame of reference at center of mass. So, coordinate of xcm will be equal to 0. Thus, we have seen that xcm is equal to 0 when the origin is taken at the center of mass. Thus, m1 x1 plus m2 x2 by m1 plus m2 will be 0, because this is the value of xcm, or m1 x1 plus m2 x2 will be 0. Similarly, we can write m1 y1 plus m2 y2 is equal to 0 and m1 z1 plus m2 z2 is equal to 0 in 3-dimension case. So, C frame of reference is also called rest 0 frame of reference, because center of mass is 0. It is the origin of center of mass. In absence of any external force, the velocity of center of mass frame of reference is itself a constant with respect to L frame of reference. If there will be no external force, then the velocity of center of mass frame of reference will be a constant quantity with respect to L frame of reference. So, C frame of reference is also inertial frame of reference. Since xcm is equal to this much, differentiating both sides, we get dxcm by dt is equal to this much, or vcm is equal to m1 u1 plus m2 u2 by m1 plus m2, where this ucm is the velocity of center of mass frame of reference with respect to L frame of reference. So, today we will stop this lecture at this point. The detailed application of this center of mass frame of reference will be done in lecture number 8. The detailed note of this lecture is given at the last of this video.